Hello everybody, welcome back to Embetronics. This is the continuation of the bootloader tutorial series. If you are coming directly here, then I would recommend you to look at the previous parts of this series for a complete understanding. Without wasting the time, let's get into the concept. What we have done in our previous tutorial. We have updated the application area directly with the application using the bootloader. Then we were calling the application from the bootloader. In this tutorial, I am going to add some more features to the bootloader as I have told you in the first part of the tutorial. I have allocated one 128 KB sector to store the configurations, and this application area remains the same as our previous tutorial. Then one 512 KB block for slot 0 and another 512 KB for slot 1. So here I am going to use two slots to store the two versions of the application. Previously, we have updated the application directly to the application area, but I am not going to do that now. Instead, I am going to update on the slot 0 or slot 1. Once I have updated any one of the slots, then the bootloader will check the updates in slot 0 or slot 1. If it has found anything, then it will write the new application to the applications area. After that, the bootloader will call the application. This is what we are going to implement today. Here, I am using slot 0 and slot 1 to store the two versions of the application, and I will copy the data from slot 0 or slot 1 to the application area. You can directly run the application from any slot without copying. If you do so, you will be having 3 slots totally including the application area. Today, we will see the demonstration first and followed by the code walkthrough. Okay, first let me press the reset button. We have the bootloader 0.3 and application 0.3. Let's erase the complete flash. Connect it and erase the full chip. See the flash memory. The bootloader area is empty. The application area is empty. Slot 0 is empty. And slot 1 is also empty. Now, we will be flashing the bootloader. See here. The bootloader version is 0.3. Reading the reboot reason. This is the first time boot because the application area is empty. So it is going to OTA mode and waiting for the data from the UART. Okay, now let me build the host application. It is ready now. I am going to send the application 0.2 version where the blue LED blinks with 5-second delay. Slot 0 is available and writing to slot 0. See the blue LED that is blinking in a 5 seconds delay. See here, application version 0.2 is running now. When the bootloader starts, it checks for the new application. The new application is available on the slot 0 as we have written the application in slot 0. So, it is copying slot 0 to the application area, then verifying the application and jumping to the application. Now, the slot 0 has the application 0.2 and I want to update the application to 0.3. So, I am pressing the reset button and pressing the user boot button. Now, it is waiting for the OTA data. Let's flash the application 0.3. Where the blue LED is blinking in a 200 milliseconds. See, now slot 1 is available. The new application is available in slot 1 and it is starting the application 0.3. See the blue LED, it is blinking fastly. Now slot 1 has the latest version and slot 0 has the old version. You can send any version of the application. It will overwrite slot 0 or slot 1. Let's see what happens if some intruder tries to change the application. I am going to modify these 4 bytes to some random data. Let's reboot the device. The bootloader hangs as the application data is changed. So it will add more security to the application. Now we will walk through the code. Let's see the application first. I have changed only the application version and reduced the delay to 200 milliseconds from 5 seconds. That's all. Build the application. Our application is ready. Application 0.1 has the 1 second delay. Application 0.2 has the 5 seconds delay. And this application 0.3 has 200 milliseconds delay. Next, we will move to the bootloader. In this bootloader, I have added some features like CRC verification for chunks as well as the application package. Then added slot 0 and slot 1 to store the application. Okay, let's go through the code. I have incremented the bootloader version. I am reading the reboot reason from the configuration flash area, which is sector 4. If this is a normal boot, then we do nothing here. If this is an OTA request from application or very first time boot, then we have to go to the OTA mode to receive the data from the host. So I am setting this flag as true. And if the application requests you to load the previous version, then we have to load the previous version. I am not going to implement this feature and leaving this to you to implement. Right after that, we are checking the user button. If it is pressed, then we are going to OTA mode. So, using the ETX OTA download and flash function, we will receive the OTA from the host. Otherwise, we will check for the new application. Look at this function. Here, we are checking for the configurations whether any one of the slot has a new application or not. If it has the new application, then we load the new application into the application flash area from that slot using this write data to flash app function. After that, we will be calculating the CRC for the new application and verifying it. If the CRC is not matching, then we will stay here and it won't run the application. Now, the application area is filled with a new application, so we will jump to the new application. Now, we will see how we are processing the OTA data. If the application has requested the OTA, then it will come here. We are receiving the chunks like OTA commands, header and data using this ETA receive chunk function. This function has been implemented already in our previous tutorial. In that, I have added the STM32 verification for all the chunks that we have received. Then we will process it using this ETX process data function. In this function, I have added 2 slots mechanism. OTA abort command, OTA start and OTA header. Yes, when we receive the OTA header, we have to decide that where we are going to write the data. So, get available slot number will return you the slot number to write. The data will be written into the available slot. Finally, we will be receiving the OTA end command. That time, we will verify the application. If everything is okay, then we will update the slot information and also update the reboot reason as a normal boot. Then, we write it into the configuration area. Now the bootloader can be able to jump to the new application. In our next video, we will update the application or firmware wirelessly without the help of a PC. Yes, I can understand that this code walkthrough is not enough, but I would recommend you to go through the code. The GitHub link is given below in the description. I am sure that you can easily get along with it. Please check our other works also. The links are available in the description. Thank you. See you in our next video.